All right, so let's look at the example again for the area based on the value for the radius that we assign at runtime. Okay, so I recopied the program we had in example 11 over to example 12, except this time I'm going to make some changes. One is I'm going to include the CMath library so that I could use the function pow or power to square the radius. So these will be the steps that I will do so I don't have to write radius times radius. Now for this example, it might be okay, to multiply something by itself when you're squaring it. But what if you had to multiply it several times by itself? An example of that, let's say, was radius to the 7th or to the 8th. Now let's suppose you missed one member, right? So you, instead of raising it to 7, you raised it to 6, or instead of 7, you raised it to 8. You're going to get the wrong results. So there's got to be a better way, right, to raise something to a certain power, right? So that's where that CMath library file will come in, okay? And where within it, we could use the function pow. Now, I've been talking about these library files, and let me show you. Here they are. Here's CMath. So if you go to Google and you just simply type C++ standard library, what you would get, let me start from here, C++ standard library. You'll get a listing here. Just go to the first one where it says C++ standard library headers, okay? So I'm going to click there. And then I get all these utilities, all of these things that have been pre-designed for you to use at any given time. And notice here in green, it shows also which version of C++ is compatible with that type of, let's say, utility. Notice C++ 11 version, now we're at 20, right? So some applications that people are starting to experiment with C++ version 20, okay? What you will see a lot is the default pre-98 C++ 11, some 17, hardly any 20, but they're a lot of fun. The 20, so the higher the version, the more utilities you're going to have, the easier actually the code will become. Okay, so stay on top of the versioning for C++. It's an interesting topic. But let's focus on one area I'm concentrating on, which is how to do CMath, right here, numeric library. So CMath is right here, common mathematical functions. Now, if you programmed in C, then you would have something called math.h. .h means it's a header file. This is equivalent to that. So if I click on CMath, okay, and notice the first thing it's going to say, this header was originally in the C standard library as math.h. That's fine. So that means now I have all the functionalities that I had in C right now in C++. And it could show you within the new version of C++, starting at 11, what other new things you have, right? Now, if you don't see like C++ 11 or 17 or 20, then you know that's the traditional C++ and C. When I say traditional C++, pre-98, if not, it's a C relevant functions. ABS, for example, like these here, are for your absolute values, right? And notice here you've got more utilities to find the max, the min of a series of numbers. A lot of goodies. Now we're interested in POW right here for our case, power functions. Now there are different flavors of POW. POW-F, POW-L, and again, depending what version of C++ you're playing with. Now, typically when I'm writing C++ program, especially for introductory, I am pretty much using C98 or C++ 98 version. Once we move forward and I need more fine-tuned utilities, then I would go to these more powerful and user-friendlier functions that I could use, and they're more refined for what you need. Notice even square root, right? You have different flavors of square root, okay? And it goes on and on and on. Now, we're interested in POW. So I'm going to click on POW here. And it tells you that POW takes two parameters, the base and the exponent, and it returns a float. Now, in our case, we're going to supply it with a double, and it returns a double. So as you can see, you could map it to the data types that you want. Okay? Right, so that means if I want to raise 3.3 to the square, then 3.3 will be my base. The exponent, it will be 2. And then the result will be returned by that function. So you better have something grabbing it, or whatever this returns will be the actual result. Okay? So let's do it in our example. Let's write the code that uses POW, okay, with knowing that our variables are, our radius is a double. So that means it's going to return a double to the area. All right, so the first thing we need is the library CMath. So I'm going to go over here, include CMath. That's step one. Number two, use the function within CMath called POW. So pi times POW radius, comma, 2. That's it. It's that simple. This function will return radius square, multiplies it, and then you multiply it by pi and store that in the area. Let's see if we get our results. Let's compile and run here. Excellent. So now let's go ahead and enter a radius of 1.2. Remember we did that before at the same value, and we get a 4.52, right? Remember I set the precision to 2 for the output, okay? So really I should have entered 1.20, right? But it doesn't matter. It rounds it out for you the way it's supposed to, or set the precision the way you set the output. We set it to 2 precision points. Now, had I set the precision to 1, and let's do the same example, okay? Let's see what happens. Compile and run again. You always need to compile if you make changes to your code, okay? So 1.2, now notice how it rounds it up to 4.5. Okay? Let's say now we want to write a program that will calculate the volume of a cube. Okay? So we want to do another example that calculates the volume of a cube, which means you only need to enter one side of the cube and we will get the volume. And this allows us to, again, review right now how to reuse CMath and the POW function. So this gives us a good review for that example. So let's go ahead and start with that. So I'm going to go ahead and do example. Example. This, where are we now? 13.cpp. Calculate the volume of a cube, right? And this again allows us to review how to use CMath and POW again. So include, we're going to need CMath. The order in which you include your library, CMath, not SMath, is not important at this stage. Include IOStream, and then include IOmanip, if you want to set the precision, that is, using namespace. And then we're going to do everything in main. Eventually we'll have programs that will require other functions. And then return 0. All right, let's compile this quickly. you save and compile, or you could say compile and run quickly. It will try to save it for you. So this will be example 13. And this allows me to change the console properties. And I'm going to set it to 36 so everything is nice and big. Okay, so now, same thing. We're going to break down our program into declaration, assignment, or assignments if you want, if there are several assignments, processing, and then output. Now this would be a typical C program, would be written up this way. Even for your controlling functions in C++ would have something very similar to this. So now we need to declare this side of a cube. We assign it a value here. We process for volume, and we output the volume. So I need a couple variables, double, side, and volume. So side will be the side of the cube. The volume will be the actual volume of the cube. Remember what I told you before, I like the name of my variables to mean what they're supposed to be doing. Here, cout, enter the side of the cube. Okay, so you're entering a value, so cin, and that would be side. Okay, use variables that you declared. Now we process. Volume will simply be equal to pow side 3. That's it. Whatever power the function power returns will be assigned to volume. Now we can output this. So you could say something like this, cout. Remember the keyword fixed. And then set precision. Let's set it to 1. And then you could say volume equal. And let's see how this behaves. So let's compile and run. Forgot a semicolon at the end of my line there. Compile and run. Okay, here you go. So what if I entered 1? Well, 1 times 1 times 1 is 1. So the volume is 1.0. Notice the precision was set to 1 decimal point. Okay, so let's run it again. And this time we're going to enter something like 7.8 millimeters, 7.8 centimeters, 7.8 inches, 7.8 yards, 7.8 kilometers, you know, whatever. That's a huge cube. 7.8 kilometers would be a big spaceship, right? So let's see what you get here. All right, so 474.6, whatever value. If it was centimeter, it will be centimeter cube. If it was millimeter, it will be millimeter cube. If it was inches, it will be inches cube as far as the unit is concerned. Okay, great. So I hope that helped understand how to use the pow function. We're going to do more examples where we're going to use other functions, right, within the CMAP library and play with them to do some conversion problems and so on. So I'll see you again for the next video.